Java has a rich set of collection classes. However, most of them are not thread safe. We need to take precaution to ensure that the collections are behaving as intended when used in a multi-threaded context. There are two ways to do so. The first approach is to use the collections.synchronized method, and the second approach is that we can use concurrent collections, which are essentially concurrent versions of the collections. In this video, we will learn about the first approach. In order to demonstrate the uses of collections.synchronized method, I have created this class called as synchronized collection. So let's start by creating a array list. Let's call this as list. And I will be creating two threads. The first one is called as 1. What this will do is it will add some value to the list 1000 times. So list.add I, and let's close this one. I will be creating another thread, and it will also add some value to the same list 1000 times. List.add I. So let's move these things to the main method, otherwise this will not work. So let's create a main method. Let's place the things here. And now 1.start, 2.start. And in order to ensure that these threads are getting completed, let's call the .join on these two methods. Second is 2.join. And now let's print the size of the list after the operation has been completed. Now let's run this program and see what is the output. So you see the output is 1446. However, we are adding value to the list 1000 times, and this is being done by two threads. So what we should have expected is that the value would be 2000. But here there is a mismatch. Let's run it one more time. And this time we are getting a totally different value. So the point here being that it's leading to some sort of inconsistency when this is being used by different threads. So how can we solve this? So one approach is to make this thing as synchronized. So as discussed earlier in the video, that there are two approaches to make use of the concurrent collections in Java. One is by using the collections.synchronized method, and the other is to use the concurrent collection itself. So here we will be learning about the synchronized method. So let's do that. And the way to do this is, let's comment it out. Let's create a new one. So list integer list, and we can call collections dot synchronized. So you see there are lots of options: synchronized list, synchronized collection, map, set, navigable map, so on and so forth. But in this case we have to synchronize the list, so we will be calling synchronized list, and we will pass an array list. So this is the way in which we can create a synchronized list using the collections.synchronized method. And based on your need, you could also invoke other things like synchronized map and synchronized set and all those things. So let's run this thing one more time and see the output. So we are getting the value as 2000. So basically list.size is 2000 now. Let's run it one more time. And now we should be getting the same value through and through. So this means now there is no inconsistency in the list, even though we are using it across multiple threads. So the list is a synchronized list now. So this is the way in which we can use collections.synchronized to help us with creating a concurrent collection. However, there are certain downsides of using the collections.synchronized approach. Let's learn about those one by one. So the first one is coarse-grained locking. What it means is that it uses a single lock to synchronize all the operations on the collection. This means that only one thread can access the collection at a given time, even if multiple threads are performing unrelated operations. This can lead to contention and reduced concurrency, especially if there are frequent read and write operations on the collection from different threads. The second is the limited functionality. And what do we mean by the limited functionality? Well, the synchronized wrapper returned by the collections.synchronized list does not expose any additional methods for fine-grained locking or custom synchronization strategies. This limits your ability to optimize synchronization based on specific uses or patterns of your application. So when we discuss about the concurrent collections, we'll try to cover how exactly those collections provide certain other custom synchronization strategies as well. So the third downside is that there are no fail-fast iterators. So collections returned by collections.synchronizedList do not support fail-fast iterators. The fail-fast iterators throw a concurrent modification exception if the collection is structurally modified when an iterator is iterating over it. Without fail-fast iterators, it's possible for concurrent modifications to the collection to go unnoticed, and this can lead to certain unexpected behaviors. The fourth downside is performance overhead. So synchronization introduces overhead due to lock acquisition and release. This overhead can degrade performance, especially in the high throughput or latency sensitive applications. So if at all you don't need these four things, then probably you could consider making use of the collections.synchronize method in your use case. But let's say if you require some of these functionalities or these features, it's better to go with the concurrent collections which are provided by the Java. So now let's start learning about those concurrent collections.